Okay, right now we want to look on the solution for slope stability problem. And in this case, what we concern is to solve for factor of safety, and we are using total stress analysis to settle for this problem. Okay, for this kind of problem, what we want to look is the equation first. This will be the general equation for every slope stability problem. So we have factor of safety given by F or FOS is equal to shear resistant moment divided by disturbing moment. And for total stress analysis, we are using factor of safety is equal to CU R squared multiplied by theta, and all of this is divided by WD. Okay, meaning that your shear moment is given by CU R squared theta, and then your disturbing moment is given by the value of W multiplied by D. Before we go into the example, so we need to define all of these terms. Cu is your undrained shear strength, and then R is your radius of the semicircle, and then theta is the sector given by your semicircle in terms of degree angle. Okay, W will be the weight of your slice or the weight of your soil mass, and then D is the position of your slice. Okay, and if we want to look all of this terminology in terms of the drawing, so let's draw the possible slope. This one is first you must do to solve for your example. So we must determine first the slope measurement. So you have your slope from toe up to your top of the slope, and then you have this flat area, and then you have another flat area in front of the toe. Okay, and then you need to identify where is the position of your slip angle, and then we need to identify what will be the radius of your slope. So this one will be the radius of your slope. If you know the measurement from the center, you can use your compass and then open your compass into the measurement of R, and then use that one to guide you to draw this semicircle, and this one is showing us the plane of weakness for this slope example. Okay, of course you must draw this one smoothly, and then we get that smooth slope and that smooth semicircle drawing. Okay, we have on both sides the radius of your circle, and what is the mention about theta. This is theta, the degree angle, okay, showing the sector governed by your semicircle. And then okay, Cu will be given as the properties of your soil. R will be the radius of your drawing. Theta will be the sector. And then next is we want to know what is W. W is the mass of soil. And eventually we will solve this kind of problem by dividing your slope into several slices. Okay, most of the time we try to make our slice is equally, the width is equal if possible, and the rules to draw this slice is when you have flat surface and then you go to the slope surface, okay, you must draw one line here. So another from slope to the flat surface, okay, you have another line here. So in between we have bigger slice, so we provide another one or another two. So in this case you have 1, 2, 3, 4 slices, and we need to know the area of this slice. Okay, every slice we need to know the area of the slice, because W is given by unit weight of your soil multiplied by the area. So if you have the unit weight of soil will be similar for every slices, because we have the same soil, unless you have multiple layer, that one is different calculation. So for weight number 1, gamma at all unit weight is multiplied by area number 1. So if you want to find W2, which is unit weight of the soil, and then you multiply by area for 2. So for this example, for this particular drawing, we know that for slice number 1, the shape of the slice is almost looks like triangle. So use triangle equation to find for this particular area of your slice. And then if we want to see for the second slice, okay, which is here, this one is more like your trapezium. So use trapezium equation to calculate for area number 2. And we have another one here for slice number 3. It almost looks like trapezium, so you will calculate for W3 unit weight multiplied by A3. And then for the last slice, which is here, so it is almost like triangle, so we are using triangle to calculate for weight number 4, which is unit weight of soil multiplied by your area number 4. Okay, that one is to know what is the meaning by W, but in this time around we have the equation that W must be multiplied by D. Okay, D is actually the position of each of the slice. So if you look into slice number 1 here, and the shape is almost like triangle, the effective position is 1/3 from the slice. So you can draw this very fine line to show where will be the position of the W1. Okay, 1/3 from it width. This one is 1/3. And then why we need to make this line and why we need to know this position, it is because you must calculate from the centroid to this position, that one is considered by D1. So WD, okay, next is to elaborate for this equation, you must calculate for W1 multiplied by D1, W2 will be multiplied by D2, W3 will be multiplied by D3, and then W4 will multiply by D4. So that is the reason why we need to draw this blue line, just to show us where is the position of D for each slices. So another important information, if you have your line centroid here, and then your D is to the left, so this value will be negative D1. So and then if we look into the slice number 2, because this is trapezium shape, so you need to draw at the center of the wedges, so up to the centroid line, and then you get the centroid to the blue line is to the right, so you have D2 is positive. And for slice number 3, of course, this gives us the line for trapezium. So we draw this one. And from the centroid to that line, it is to the right. So you have D3, and that one also is positive value. So looks into your drawing number 4. Okay, this one is almost like triangular section. So the effective position will be 1/3 of it width. So this will be the position. So take this one line to the centroid, and you have D4. That D4 will be positive value for the slice number 4. So we already defined what is WD. Okay, each of the slice will have its own value for W. Each of the slice will have its own value for D. So for my example here, the sketch gives us 4 slices. So to elaborate the equation, that will be W1 D1 plus W2 D2 plus W3 D3, and then plus W4 D4. So but again, you need to have that shear resistance moment given by CU r² theta. So CU is the properties of soil. R you will get from the geometry of your drawing. Theta is from the geometry of drawing. That one is the measurement using protector. So that will be the overall explanation when you have the equation. When you have the question asking you to find the value of FOS, and the value of FOS for analysis, and this analysis we call it as total stress analysis. Okay, the best part of this is to draw your drawing, or to draw your question. Okay, from the question given, and then from the question you must transfer the drawing on your graph paper. So we will see how to draw. Okay, so right now we want to understand the theory and to apply the theory to the question, and this will be the word example question, or example 5.1, that you can use this example to enhance the knowledge you have earlier. So first we need to really understand the question given. For example 5.1, for the slope shown below, determine the factor of safety for the slip surface AD based on total stress analysis. Divide the slip circle into 5 slices. Redraw the cross section of slope with recommended scale of 1 centimeter equal to 1 meter in the graph paper. Ignore the possibility of tension crack. Okay, we will discuss about tension crack afterwards, but right now let's see what is the requirement for this example 5.1. First thing is the example asks us about FOS, or factor of safety, and then the question also asks us to solve this one using total stress analysis. And the requirement to draw is to provide with the slope with 5 slices. and the scale needed for this particular example 5.1 is 1 centimeter equal to 1 meter in the grass paper. So this is also information that important. We ignore the possibility of tension crack. Okay, the application of equation that we want to use is F of S is equal to Cu R squared theta and then divide by WD. Okay, I forgot to mention about theta. Theta, you use your protractor, you get the value in terms of degree. But in the calculation, before you insert the value of theta, you must convert that theta to radian value. So then you solve for F of S. So right now, of course, we need to identify what is the value for Cu. Cu given in the drawing. This is Cu, which is 22 kilonewton per m squared. And then the properties other than Cu is we want to know about the unit weight of soil, and given the unit weight of soil is equal to 17 kilonewton per meter cube. So we have all the requirement needed to redraw this picture on your graph paper. So if I need to draw this one, the first thing is I need to look on all the measurement given. Okay, the first one, of course, this vertical line is very important for me. Okay, from the top of your slope to this point, and this point is related to the point you find the toe of the slope. So that's why it's about 6 meter. Okay, next from the toe of the slope, okay, it give to this point is about 9 meters. So this is also important information for me before I want to draw this drawing. And we have another information from toe to the front. It is limit to 2 meter. So I know what will be the limit for the horizontal line in front of the toe of the slope. And next is for me to know what is the position of centroid. So from this one, okay, up to the centroid here. So I have another information which is 3 meter. So I can use compass to open this measurement and draw the slip circle, but I also can use the theory of theorem Pythagoras. So I have 8 meter, this one is 2 meter squared. So I know this measurement here is 8 squared plus 3 squared. All of that one is square root. And then you get the answer, you know the measurement for the radius. Okay, radius, either you use your compass to measure your radius or use theorem Pythagoras and then you get the value for radius. Okay, use this one and then you want to draw this circle up to this point before you can draw all the slices needed for these particular questions. So it is important for us to understand all the measurement. Oh, this one is also important here. From the centroid of your drawing, okay, up to this point is about 8 meters. So I'm sketching all of this line first, then I will draw using thick line to show the position of my slope, the position of R, and all requirement, all important requirement for this slope drawing. Okay, next is you need to take out your graph paper and then read.